Hi everyone, my name is Ranga. I am here to explain you about the application of stacks. Some of the application of stacks are converting a infix expression to the postfix expression and converting the prefix expression into the postfix expression and evaluating a postfix expression. In this video, we we completely go through the evaluating a postfix expression. Before going into the video, let us understand what is stack. Stack is a linear data structure in which operations like insertion and deletion are performed at the same end. The element which is inserted at, inserted at first will be popped at very last. This is how the stack works. Before going to the evaluation of an expression, just know something about the postfix expression. Why the computer only needs postfix expression instead of postfix expression? Because it, it is difficult for the computer to identify the priority and parenthesis. It makes computer too difficult to evaluate the expression in the form of infix or prefix expression. If you give the postfix expression to a computer, it is easy to it to convert to give a perfect result. Okay, let's go through the algorithm so that we can understand it in a easy way. Postfix expression is also known as reverse polish notation, a mathematical notation where every operator follows all its operands. It is an expression which contains both operators and operands. Op- Here you can see the difference between infix and a postfix expression. In infix expression, operators are operators are included between the operands, but in case of postfix expression, from left to right, we observe that the operands will come first and then operators. Before going to the algorithm, let's have some terminology about this algorithm. Operands. Operands are the numbers that are which are constants which on which the operators will work. Operators are the symbols which works on operands. The algorithm. First, we need to uh, create a empty stack. Read the read the postfix expression from left to right. For each token in the expression, during the expression reading from left to right, you, if you find the if you find an operand, we push it into the stack. Else, if we find an operator, we pop the topmost two elements and perform the operation on them and again push the result into the stack. These process will go on until the elements in the postfix expression goes empty. The final result will be popped and display on the screen. To understand in easy way, let us go through an example. Let us consider a postfix expression that is 5 6 2 plus into 12 4 divided by minus. If we read the given expression from left to right, first we find the operand 5. Since it is an operand, we push it into the stack and again we find an operand 6 again we push it into the stack, and we find 2, again we push. Here you can see we are pushing the elements 5, 6, 2, and then we find an operator plus. Whenever we find the operator, we pop the pop the top two elements and perform operation on them. Here you need to consider one thing. We need to perform operation between the last popped element and the first popped element. If we consider, for example, if we here we consider there's we first pop the element 2. Let find us an operand 4, which again be pushed into the stack. If we observe the postfix expression, we find the operator division, and we pop the top two elements and perform division operation on them. Here we perform the division operator between the 12 and 4, which gives the result 4. The result 3. The result 3 will be pushed onto the stack again, and again we go through the postfix expression. Here we find the operator subtraction. We perform the operation on top two elements, that is 40 minus 3, which gives the result 37. The result 37 will be displayed on the screen. And understand the let us understand the code for the above algorithm. Here if you, it is the is a function which is used for the function postfix evaluation. Here we initialized a function to evaluate the postfix expression. Here I am initializing the variables I, a, b. For loop, in a for loop, I initialize I to 0 and I less than 7. Here is some mistakes. Note that it is a strlen of postfix expression, which reads until it finds the operator null. It goes on. It goes on for the operator null, element null. If the element is if the element is character if the element is less than or equals to character 0, and and the element greater than or equals to less than or equals to 9, the given element be pushed into the stack. Here we are using the character 0 so as to convert the gi- uh, taken elements into the integers. If you take the element 5 here, and let us the 5 be taken, and 5 is greater than 0. Character postfix of 5 is greater than element character postfix of 5. Character 5 is greater than character 0, and character 5 is greater less. Character operator is division. We push the top two elements and perform division on them. Finally we pop the result from the stack, and display on the screen. This is all about the evaluation of postfix expression. Space, time and space complexity of the post evaluation of postfix expression. For evaluating a postfix expression, the order of time complexity is order of n, and each token is preceded once, and space complexity is also the order of one for storing the operands in the stack. Maximum stack size depends on the expression length. Applications of postfix evaluation. It is used in compilers for expression parsing, postfix and also postfix calculators use this logic to solve the problems. Simplifies it also simplifies syntax analysis in interpreters and VMs. Okay, friends, this is all about my topic, that is postfix evaluation of postfix expression. If you like this video, please click on the like button. If you have any doubts, you can ask me in the comments. Thank you.